So yes, hidden complexity. Has anyone used Simple.Data or SimpleWeb at all? Just a couple of people. Do people know what it is, roughly? So for those who don't, Simple.Data it's like an ORM, and when you use it, the code you write looks like an ORM, but there's no code generation, and there's no mapping files and all that sort of stuff. It just kind of does it dynamically for you. And SimpleWeb is like what Web API should have been before Microsoft broke it. And so, but the two, one's a library, one's a framework, and there's a difference. But basically, the idea is that you write as little code as possible, apart from what you have to write to express your application. And so the code that you write is very, very terse, very, very brief, no ceremony or any of that kind of thing, no code generation at design time. And behind that, there is an insane amount of very, very complicated code that's trying to make sure that everything you're asking for happens as quickly as possible. And people just go, oh, you're really awesome because you wrote this thing. And it's like, I'm not. I just kind of found things on the internet and learned a whole load of stuff. And so this talk is just some of the cool stuff that I've learned while I was writing these frameworks that you can use in your own projects occasionally. And actually, I use both of them. I have Simple.Data and SimpleWeb, and they're both on GitHub. And I'll go and raid them when I'm working on other projects, and I'll think, oh, I've done that in Simple.Data. I can just go and grab that class out of there. And so for me, it's a great resource. So it's been a learning experience, but it's also just my repository of clever code snippets. And when I'm done, and if anything in there looked useful, do feel free to go to my GitHub and just browse through and find bits of code that might be useful to you and nick them, because the whole thing's MIT licensed, because I'm an idiot. And yeah, you know, fork it and charge money for it, and there is literally nothing I can do to stop you. So that's a vague Wizard of Oz style quote, which I'm not sure is going to translate properly. But generally, when people are using Simple.Data and SimpleWeb, I say, pay no attention to the code behind the curtain. And today we're going to actually look at some of that code behind the curtain and use some of these things as tips. And the first tip is actually a really simple one. And it's use dynamic for TDD. So let's have a show of hands. Who's a C# developer? Pretty much everyone. OK. Some VB.NET guys? Yeah, Ruby, Python, JavaScript. So you guys who are doing Ruby and Python and JavaScript, TDD, when you're working in a dynamic language, is really easy because there's no compile phase to get through. You just go, I'm writing my test. It doesn't pass because that class doesn't even exist yet. I haven't written it, but it's a failing test. If I switch across here to my demo application. So I use nCrunch, and fortunately Greg Young isn't here yet, so he can't punch me for that, because Greg writes continuous tests. But I use nCrunch. I like nCrunch because it means that down here in the bottom right corner of the screen, I have my little risk progress bar, and that will tell me how many failing tests I have. So when I'm working on Simple.Data, I have like 800 tests, and it tells me that I've just done something, and now 6 of them have started failing, and I've broken something somewhere. But because C# is a static language and it's a compiled language, if I do something that stops the application from building, then all that information about how many tests I've got and how many of them have passed goes away and just gets replaced by this one red build error, which is just saying it's not building. Once it's built, all the tests might pass, or none of them will pass, or half of them will pass, but right at the moment, all I can tell you in this little window down here is that it's not building. And if I just change one word here and let nCrunch do its thing, I get one test failing. And that's because I've said, actually use a count as a dynamic variable, And the test is failing, it's getting an exception thrown, and it's getting a C# runtime binder exception that's saying target.disable doesn't exist. And then I can just go across to my account class here, and I can uncomment the code that I commented out, and go and uncomment that, and then go back to here, and then that's fine, and that test is now passing. But I'm getting the information out, okay? So that's, and if I show you sort of one of the tests from Simple.Data, which is where I picked up this useful tip from, nope, not you, you, and we'll just pop into here. So in Simple.Data, the database type that you get back from it is dynamic. And that means that I can build tests like this. So where I get my underscore DB here is a dynamic type that's returned back from Simple.Data. And so when someone says, oh, I really wish I could get a magic count when I'm doing a skip and a take, I'd like to get the overall number of rows, I can just write a test which has got the syntax that I would like to work, and then I just keep fixing the bugs and the exceptions and stuff until that test passes, and then I check it in. And that's proper test-driven development, and it's because I'm using the dynamic keyword that I can do that. And that's why Simple.Data has 800 tests, whereas SimpleWeb, which is statically typed, has nowhere near that number of tests. Because it's not a discipline thing, it's a how easy it is. And if you use something that makes it easier to do something, then you'll do it. So that's useful. But what if the account class doesn't exist yet? What if you're about to start developing a new component for your application and you just don't have that class there yet? Well, in that case, you can put in a customer test here, and I use this construct down here called a target factory, and I can say target factory.instance. What I actually do is I create a thing that uses activator.createInstance, and so I pass the class name as a string into a factory, and it goes into the dynamic mode, and then it returns the thing back saying null, and then I get a null reference exception in my tests. But I'm still maintaining that dynamic chain, and then I can go and create the class, and the test runs again, and now it says that class doesn't have this method, and then I create the method, and it runs the tests again, and I'm kind of drilling down and getting this thing, and nCrunch is just sitting down there in the corner, driving me through the code. So yes. So that's the first tip. That's quite a simple one. And then, so who is that useful? Yeah? Yeah, okay. So I haven't completely wasted everybody's time, even if the rest of it's crap. Right, using dynamic object. So dynamic is this awesome thing. I was talking to Scott last night, and he was saying, has everyone taken a look at TypeScript? Basically, Anders Halesberg, the guy who did C#, has created a superset of JavaScript, and he's put static typing on top of it, and it makes JavaScript a little bit better. And it just kind of turns up the typing on JavaScript a little bit. And when they put dynamic into C#, it just turned down the static typing on C# a little bit. And if you just fiddle with that dial, you can actually turn the static typing on C# all the way down to 0 and just use dynamic for everything. The performance isn't great, but you can do it. You can't do that the other way with JavaScript. JavaScript is always going to be dynamic. There's nothing we can do to fix that, he said, to wind Rob Ashton up. But Ruby and Python, which are kind of dyed-in-the-wool dynamic languages, both have this thing. In Ruby, it's called method missing. And in a class in Ruby, you can define a method called method missing that will get called whenever you try and call a method and it doesn't exist. And then you get all the information about that passed in there, and you can say, well, if they called this, then probably what they meant was that. And ORMs and this sort of stuff use this for creating magic methods that are just kind of passed at runtime. And when Microsoft did C#4 and the dynamic keyword, they also introduced the dynamic object behind that, so you could effectively implement this method missing thing. And that lets you do some really cool stuff. So if we go into fun with dynamic objects, and we'll close everything else down.
One question.
Yes, hello. Questions?
You place dynamic after you finish your test, because then it's easier to refactor something.
I completely forgot to say that. Yes, sorry. Once you've got that test passing, if you change the name of the class, so you change it back to var, once the test's passing, then refactoring will work and it will find its way through into your tests. Although there are people who would argue that actually, if your tests need changing because you've refactored your code, then you're not refactoring, you're refuctoring. So yes. So here, right, is the code big enough, by the way? Have I set my font size large enough for all you guys at the back? You don't care, you're just whispering and passing notes anyway. So one of the classes that came along with dynamic is expando object. And expando object is basically just this big open object. It'll take any property that you want and you can add methods to it and all this sort of stuff. And so I can say, create a new expando object and then set expando.fish to halibut. And I can run that. Let's set it as the startup project because that's always good. And there we go, that says halibut. And you think, well, that's probably quite complicated to do that, isn't it? And actually, no, it's not. Down here, we've got a class called sillyputty. And if I change this type here to sillyputty and run that again, I've made a class called sillyputty that does exactly the same thing and bizarrely does it faster. Expando object is not a fast class. It's a clever class, it does interesting things internally, but it is not speedy. And all I've done there, I'm just going to close that one down for a second, is I've derived my class from dynamic object, and I've overridden trySetMember and tryGetMember, which are methods that are called when someone in code tries to set a property or get the value of a property. And I'm literally just passing that through to a dictionary, a string object, and storing things in there. That's it. That's all you have to do. It's not particularly complicated. But if you get creative with that, if you think of that in terms of, say, a WPF or a Silverlight view model to be used in an MVVM application, then you can create a kind of expando object notify property changed and actually put in your iNotify property changed implementation just into those two methods, rather than having to create a view model with 50 properties on it and the same code over and over again because Microsoft won't let you write macros. My #1 wish in C#, macros. What does Anders Halesberg hate most in the whole world? Macros. I'm never getting it. Maybe Roslyn, so yeah. So yes, it's that simple. And you can literally just put in the trySetMember call to notify property changed. And suddenly you've got a view model that is just working like magic and you can set properties on it in code. And if you're getting really clever, you can actually write a view model that wraps around a model and just uses reflection to pass properties backwards and forwards to the model. So then you've got that thing where the MVVM purists are saying, oh, you shouldn't bind directly to the model. And you can go, I'm not. I'm binding to a dynamic object that binds directly to the model. Are you happy now? No, I'm never happy. I'm a purist. You haven't got enough behaviors in your XAML. I don't like XAML. I like HTML. So yes, but you can get more interesting with this. So try invoke member. So Simple.Data does this thing, if you don't know, where I can say var db equals database.openNamed connection, and I get a dynamic type back, which represents that database. And then I can say db.customers, and that's using the try get member, and it's going, that's probably a table called customers. And then I can say .find by ID 42, and it will go find by, well, that's select star from ID 42, where ID equals 42. I'll just run that against the database. And it just pulls apart every method and every property that you pass through to it and works out how it applies to the underlying database. It is quite clever. You should use it. And that's using try invoke member, which gives you this brilliant type here, invoke member binder, which has got all sorts of information on it. And if we go up to the custom example up at the top here, we've got a dynamic variable equals new silly putty, and then just call variable.say, and then pass in named arguments to it. And there is no say method, and the named arguments could be anything you want. And so we can actually go back up to the top here, and we'll just take those two comments out and run that again. And you'll see that that's saying hello to Bob and goodbye to Alice. And it's doing that. It's actually pulling program data from our syntax. That's not what I wanted to do. There we go. So yes, it's actually using the named parameters values effectively. It's using the names of the named parameters as strings. So it's like magic strings without the quotes. And sometimes that's better. And sometimes it's not. So yes, and dynamic objects, you can override try invoke member. You can actually override try invoke. So you can just create a class that derives from dynamic object, and then when someone tries to call it as a function, it can do something, which is quite cool. Or you can override try convert, and then when someone takes your dynamic object and tries to assign it to a strongly typed variable, say of type customer, you can just go, hell, have I got all the properties for customer? Yes, I have. I'll just create a customer class for this guy from that. And then he can go into strongly typed. And you can basically override anything that can be done to an object. You can dynamically intercept and do cool stuff with it. And you can write some really interesting code, and you can cut some really interesting corners. And I should point out at this stage that none of this is considered best practice, but it is considered fun, useful, time-saving, and interesting. So it is best practice in Ruby. I'm just going to leave that hanging there, because it would be too easy to throw oranges at it. So yes, that was dynamic object. Okay, this gets more fun. Abusing operator overloads. Who's overloaded an operator in C# ever? Yeah, you would have. It's great. This is one of the things that it does let you do. It's not as good as Ruby's operator overloading. In Ruby, you can do things with the bang and the equals and just... You can basically override anything. You can do string divided by string equals the path with the system path delimiter. So if it's running on Unix, it'll put a /, and if it's running on Windows, it'll put a /, and there's a kind of XPath library that does interesting things in Ruby. You can't quite go that far in C#, but you can go way further than you should. So let's take a look at my find test here. So I have a find method in my tables that takes an expression. And that says db.usersID equals 1 and ID equals null. And it's got an OR in the middle there. And these are dynamic things. So db.users.id gets resolved as a column, and the other side of the thing is an integer, obviously. And it looks like a link expression, except it's not a method. There's no lambda syntax there. And the reason for that is that lambda expressions can't involve dynamic, because Anders is lazy. And he just couldn't be bothered to make that work. But no, so it's using operator overloading, and it's actually come out sort of much, it's easier, because you're not having to do the whole lambda syntax and work out what you can do and all that sort of thing. So we're just going to switch back into demo here, and we'll open up operator overloads, and we'll close everything else, and we'll just shut you down there. So there I just have console write line, new column equals 1. And there's no dynamic at this point. I don't need dynamic now because operator overloading is built into the static typing inside Visual Studio. So I can just have fun with that, and I can say, no, I need to set the startup project. How many talks have you been in where the presenter doesn't remember to set the startup project to the next thing? And he goes, why is it doing that? So yes, there you go. That's printing out. So I always remember to increase the font size in Visual Studio, and then I don't increase the font size in my console window. Bear with me for just 1 second. And I am going to change the font to Consolus and make it 16 points. And there we go, that's a bit better. Okay, so what I've done is I've come up with something else from column ID equals 1 and returned a new type. And what I'm actually getting there is in column, I get a warning there saying it doesn't override it. But I'm overriding the equals and the not equals operator. That's quite common, because if you ever implement custom equality on an object where you override equals and you implement I_equality of t and you override get hash code, basically you just hit Alt-Enter in ReSharper and let it do everything. Then you'll get this operator overload. But generally that returns true or false. And you're saying, does this thing equal this thing over here? In this instance, we're not returning true or false, we're returning my expression. And my expression is just a representation, much like an expression in link, which has got a left operand and a right operand, or for your purposes, a left operand and a right operand, and an operator in the middle. And that's good, that's fun, you can do that. And then you can start throwing things around that you've constructed by abusing these operator overloads. Expression is down here. And you can see that it's got a left and an operator and a right, and it's just passing those things through there. That's a simplified version of the Simple.Data code. If I this is where it gets interesting, is where you want to group stuff together and put in Boolean logic into your equality as well. So with the equals, you can also override less than and greater than, and less than or equals or greater than or equals. And you get to this point where you're overriding the modulus operator because someone's asked if they can find users where the modulus of their ID is 0. And you're just going, really? But overriding all those operators is basically very straightforward. You override the maths operators and you start returning a math expression instead of a logic expression, and you can get into all of that. If you ever try to overload the Boolean and the Boolean or, you'll get stopped. You can't override those. You can override the bitwise and the bitwise or. And there was a release of Simple.Data where that was how you combined things together. And I wrote a little blog post complaining that you couldn't override double and double or. And John Skeet read it and went, yeah, you can. You just don't know. And he said, you override the the bitwise and the bitwise or, and then you overload true and false, because true and false are operators. Yeah? True and false are operators, and you can overload them. And you overload them like this, you see. Because normally, the true operator will return true, and the false operator will return false. And if the true operator returns true, then the C# compiler and the JIT compiler and the C# runtime will just stop. They'll just go, I don't need to carry on, so they won't do the rest of your stuff. If you override true to return false, and the only reason I'm overriding false is because these are, so when you override operators, you have to override the inverse of that operator. So when you override double equals, you have to override not equals. When you override greater than, you have to override less than. And when you override true, you have to override false. So yes, they both return false, and they force the compiler and everything else to carry on evaluating the expression. And at that point, you can use the double and the double pipe symbols in your expression. And the really, really nice thing, the thing that I just got completely for free, and people just went, that's awesome how it does that. And I'm like, yes, I know, it took me ages. Is that the parentheses that you put around things to group bits of Boolean logic together just work. So when I'm putting the thing that says expression and expression equals a new expression, the C# compiler or the JIT or whatever it is just takes care of the precedence and the grouping and all that stuff for me, and I just get the expressions put together in the right order. And effectively, all Simple.Data then does is it processes those expressions into the underlying SQL for the relevant database. Or, you know, people are writing other adapters for Simple.Data now, so there's a guy's written an OData adapter, and it just passes those expressions and represents them as $filter. And passes them as the part of the URL. And there's a guy who's done a Mongo thing, and it turns them into Mongo criteria. It's just this layer in between. So yes, there you go. That is how you override and or in C#. Never do that. Because the next person who comes along and looks at your code will just go, what? This is the main problem with using Simple.Data. If I get hit by a bus, there is no one on earth who can maintain this code. And it's not that I'm like an awesome programmer. People look at it and just go, oh, wow, this guy, and I'm not. I've just kind of built it up a bit at a time, and a bit at a time, and a bit at a time. But there's bits in there where I kind of look at it and just go, wow, that's, like I say, I go back to it because I need bits of code that I wrote, and I can't remember how I solved the problem. I found 3 pages on Google and something on Stack Overflow and put it together into 6 lines of code. And then I promptly forgot it again and carried on with my life. So I go in there and I grab it. It's a great reason to write an open source thing or to actually kind of build a project, just to build up this list of code snippets where you go, I know I solved that problem, it's in there. And then make it open source, so I can nick it too. So, Meth, Managed Extensibility Framework. Who's using Meth at all? So, who doesn't know what Meth is? Okay. So Meth is not a dependency injection container, but if you ever meet Glenn Block at a conference, ask him if it is, because he loves that. Actually, say, Mark Rendle told me to ask you, is Meth a dependency injection container or an IOC container? It's not. So an IOC container, dependency injection container, is something that creates new instances of objects for you and passes a whole bunch of interfaces into its constructor, because that's what dependency injection is. Meth is something that you give it an object that's already been constructed, and that object has got properties with attributes on them that say, I should be many instances of this interface, and Meth will go and find all the possible instances of that interface in your running application and set that property to one of each of them. And so it's great for writing plugins. So dependency injection is for things that your application has to have in order to run. Meth is a composer, which is things that your application might have in order to run. So that's the difference. Simple.Data uses Meth to compose everything together, and basically it says, have I got something that understands this data source connection string? Yes, I have. Let's carry on. And so I was using Meth to build things up, and I had a lot of interfaces. And you'll see this pattern a lot of the time, particularly with plugins and plugin architectures, where you're saying to the people who are writing the plugins, here is an interface that you implement. And then you go, I want to add a new potential feature that you could put in there. And you instinctively just go, well, I'll just add another method to that interface, and I'll break all the existing plugins who will have to rebuild because they haven't implemented that interface. And eventually you'll get to the point where plugin authors are just going, right, I'm just going to load it up, I'm going to hit Alt-Enter, it's going to fill in those, I'll leave the not implemented exception because I have no idea how to implement that functionality. And then you're having to put try catch not implemented exception into your code to cope with those times when someone hasn't extended the interface properly. And the more people that are writing plugins and the more plugins that are out there, the more of a problem this becomes. And it may just be that you work in an enterprise and you've written this core system, but you've got like 3 or 4 other development teams who are writing plugins that attach into your thing. And you can't break the entire system just because one of those teams needs to add a new feature and all the others don't. So who knows what SOLID stands for? Haha. Really? The whole thing? Oh, okay. Who did the talk? Someone. Bob Martin? He's generally the only person. So SOLID, single responsibility principle, open-closed principle, Liskov substitution principle, interface segregation principle, and dependency inversion principle. Liskov substitution principle is only in there so that the acronym is not SOID. It basically doesn't, it does mean something, but you know, it's not like the other 4. But what I'm talking about here is the interface segregation principle. So if you have an interface that is used for a plugin and you want to add some optional functionality, you don't add another method to that interface, you add a completely new interface just with one method on it. And then you can just, within your code, use getAdjacentComponent, which is just this very short method that I wrote. And you basically say, OK, so here is my plugin with the absolute must-have methods without which nothing makes sense. Now I'm going to use Meth, go just into the assembly that that plugin came out of, and see if there is an implementation of this interface. And I'm going to do that once. And if there's not an implementation of that interface, I'm going to put in a default implementation of that interface that just does nothing, but doesn't throw an exception, just does whatever it is in some other way. So a good example of this is iBulk inserter. So Simple.Data has providers. So Simple.Data has adapters and providers. The adapters are for completely different databases, data stores. So there's a Mongo adapter, an OData adapter, an Azure Table Storage adapter, and an ADO adapter. And then the ADO adapter has providers for SQL Server, Oracle, PostgreSQL, MySQL, SQL Anywhere, fucking Infomix. And people maintain these. I do the SQL Server one. That's what I use to test and make sure everything works. Other people do all these other things. And all those databases have a kind of bulk insert optimization that they can do. So rather than running an insert statement 50,000 times when someone wants to put a load of data in SQL Server, you can use SQL bulk copy. So I wanted to give the people who are writing the providers a way to say, I know how to do a bulk insert in a better way than running 50,000 insert statements. But if they were writing the provider for a crap database, like MySQL, then I didn't want to force them to implement that. How many people did I just really annoy with that? If I haven't alienated everyone in the room by the end of the talk, then it's not a good day. So yes, I put in this iBulk inserter thing, and then there is a SQL bulk inserter, which uses SQL bulk copy. But there is also find all references. That's the fella there. So in the code inside Simple.Data that actually doesn't insert many, there's this thing where it says go off and try and get a custom provider. But if I can't get a custom provider, then I will just use the default bulk inserter, which is just some internal code that will just run 50,000 insert statements, because that's better than crashing, probably. Some people don't know what this is. If you don't know what that is, it's the null coalescing operator. It's one of my favorite operators in the entire world. It's a lot like doing pipe in Java, JavaScript, rather. It basically says if the left-hand side of the operation is null, then use the right-hand side of the operation. If I just patronized every single person in the room, I apologize, but people have come up to me afterwards and gone, what was the question mark? So I say it. If you did know, then that's fine. If you didn't know, you do now, and you can pretend you did. If I'm talking too fast, please do tell me to slow down. So yes, that's just a useful tip if you're writing something that uses Meth, or something that uses any kind of plugin system. You don't necessarily have to be using Meth for that. I do, because it makes life nice and easy. But any kind of plugin system, anything where there is the potential for an interface to throw not implemented exception, then that shouldn't be there. It should be on a separate interface, which the class can also implement if it wants to. And then you can say, can I put this as this interface? Cracking example of this in the base class library is array, which implements iList of t. So array of int implements iList of int, which gives you a method add int. Call add int on an array, and your program will crash. Because array isn't a list. A list is something that you can add items to. An array is not a list. An array is a collection. It's not even a collection, because a collection's got add as well. An array is an array, basically. And you know, they were great in the 80s, but it's a list of locations in memory. That's what an array is. It's not whatever the hell it's become now. Or it's a hash table, of course, if you're a JavaScript programmer. That's fun too. Okay, so last one. Got 15 minutes left to cover this, and that's about right. I think that works well. Who's done any runtime code generation? Who's used il.emit to do runtime code generation? My God, that's fun. Whoever did assembly language? Old guys. Oh, wow, quite a lot of people. Who did Z80 assembly language? Wow, yes. Similar, 6502? That thing, yes. Whatever that had. Zilog, whatever. So yes. Until .NET 3.5 came along with Link, the only way you could generate code, well, no, there were two ways. One was to generate C# code and drop it out to a text file and compile it and then dynamically load the assembly, which was far too easy. And so you couldn't do that. That wasn't hardcore. So you had to use the reflection.emit things, and with opcode put this on the stack and put that on the stack and then call that function and then pop the return value off the stack. And it was basically writing assembly language in C#, except it was made even harder because you couldn't read the assembly language properly because there was bloody C# all over the place around it with syntax highlighting just messing up stuff. But that was it. And then .NET 3.5 came along, and because they needed people to be able to dynamically construct criteria to pass into link queries, they made the expression tree a writable entity. But it was limited. It had to be just an expression. So it was just a single continuous block of code that resulted in a value with ands and ors and all this sort of stuff. And then when .NET 4 came along, they went, actually, we'll let you build entire methods, and lambdas can wrap entire methods. And it became much more powerful and much more of a functional programming thing. And suddenly this became a real useful way to generate code at runtime, which can sometimes be useful. So let's go into CodeGen here. And we'll close all but this, and we'll save that change. I will put this, this demo application somewhere you can download it, probably in Dropbox rather than GitHub, and I will tweet a link to it. So if you want it, follow me on Twitter. Ha. That's another 200 followers. That will bring me 0.0000001% closer to Scott Hanselman. So yes, here we have some code that is going to go through a dictionary and look for properties in it and copy them into a class. And this is similar to the code that is called in Simple.Data when you take one of the dynamic record objects that I return when you do a database query and then try and assign it to customer or employee or motor car or whatever your actual static class is. Simplified version of that, basically. So let's collapse that down. So here is the basic brute force way of doing that. We have this convert method here, which is a generic method, and we say t, where t is new, and then I'm going to create a new instance of t, and then for each property in t, I'm going to see if the row dictionary contains that property name, and if it does, then I'm going to call property.setValue. And this works. This is a way of dynamically running code at runtime. And if we run that in this loop here, and we run it 1,000,000 times, then that will sit there for a couple of seconds. So how long was that? 3.3 seconds. So if you're doing that on a hot path through your application, a hot path is one that gets run a lot of times during the course of your application running. So something that adds just a couple of extra milliseconds to a hot path over the course of a day, over the course of 10,000 users all hitting the service simultaneously, that is something that you need to try and optimize out. And it's not actually as difficult as it used to be. So we have a useConverter method here that is just going to create a converter, and that converter that it's creating is a func that takes in a t and returns a t result. And the t that it takes in is an iDictionary, a string object, and it just does that. And if I go back up to the top here, we can say use converter as well. And if we run those side by side, we can see that using reflection dynamically takes 3.4 seconds roughly, and using the converter, whatever magic that may be, takes a second. So we have actually sped things up 3 times. And when you're writing this low-level code where you need to be as non-invasive as possible and you're competing with the guys writing Dapper to see who's the fastest, you need that kind of optimization. It's like processor cycle golf. I got a birdie. Golf fans in the room? Wasn't the Ryder Cup awesome? Just, oh, yes. We don't care about golf. Talk to us about programming. Oh, I'm doing it. I'm doing it. So, effectively, what you're doing when you use code generation and expressions is you're taking this cycle of code that you've got here, and you're saying, I'm going to get that contains key method, and I'm going to get that set value method, and I'm going to wrap those in function call expressions and test expressions and this sort of thing, and I'm going to compile that into a lambda, into an anonymous delegate once. So all this reflection code that's being done there in a loop gets run once, and then you get a compiled expression that is just as fast as if you had actually written it and compiled it into your application. And invoking it is just as quick as calling a regular method, because the dynamic invoking and code gen and all this sort of stuff in .NET 4 and version 4 of the CLR is actually that quick. There is almost no overhead at all. We're talking like 0.00 something of a millisecond. So if I go back to converters, you can see that I've got a method info contains key, which I'm getting from the dictionary. And I've also got a property info indexer, which I'm using to hold the indexer property on the dictionary of string object. So that takes a string. And then you can kind of follow through the rest of the code quite easily. So I've got an expression.parameter. That means that's something that's going to be passed into my method. And I tell it what type that's going to be. That's going to be an iDictionary of string object. And I've got an expression variable of t. So that's going to be where I hold my new object that I'm creating. And then I've got a constructor. So I can just do get the constructor of t, the one that takes no parameters. So type.empty types. If you're ever doing a get method or a get constructor, you really should, just in case there are overloads, you need to tell it particular overload that you're going for. And if you're going for the one with no parameters, then type.empty types is a static array that's there for you, so you don't have to say new array of type 0. And then we just say expression.assign. So here we've got our target constructor, and here we've got our target. And then here we say expression.assign target, expression.new target constructor. So it's readable English. It's much more readable than the opcodes that you were using, and also it takes care of a whole bunch of stuff for you. Actually, what this is doing under the covers is reflection.emit. It's just put a nicer slant on it for you. And then down here we've got, for var property info, we can create an expression.property, and we can create an expression.constant, which is where you would have just a string in your code, and you then have an item property, and you've got a convert that takes the object out of the dictionary and forces it into the type there. And then down at the bottom here, we just say expression.ifThen. And the first thing that we pass in is an expression that returns true or false. And the second thing we pass in is an expression to do if the first expression results to true. Is everyone following this? Just all stick your hands up, because otherwise people will think you're stupid. And then down here, the other possibility, of course, here is that I think all this is really hardcore and awesome, and you're just going, I know this. Why are you wasting my time? That's the thing that keeps me awake at night. That's what Scott was talking about, the phony thing. I honestly believe sometimes that this is just completely ordinary, and everyone's just going, yeah, we know. Go whoa. So yes, and then you put them all into a block, and then you put the block into a lambda, and then that gives you an actual, like a func or an action, whatever it might be, that you can then call into. So that's quite fun. And I did this for Simple.Data to optimize the creation of static objects. So you can say customer C equals db.customers.get42, and it will return the dynamic object from whatever the underlying data store is, and then that dynamic object will use this cached generated code here to convert itself to a static type. And then I came to write Simple.Web. And that got really hairy. Because in Simple.Web, if I just open up an example form here from my little sandbox thing, get form. So in SimpleWeb, you basically, for every single URL in your application, you create a separate class. which is a really good pattern. I call it model view handler. But effectively, it means that if you need to add a new URL to the application, you don't need to check out a controller and do work on it, and then someone else checks out the controller to add another URL, and then you do a check-in, and you've both added two methods in the same place, and TFS or Git or whatever just chucks a complete wobbly and says, no, I can't do this, and then you effectively, one of you has to do the other guy's work again, and it's just inefficient. This way of doing it, every person who's working on a URL is working on a separate class. And so that's quite cool. And it also means that you have your kind of like public method that you need, but then you can put any private methods related to the running of that class into that class, and you're not kind of creating this controller with thousands of lines of code. And if you're doing dependency injection, you don't need to inject 4 dependencies when the URL that you're calling doesn't actually need any of them, because they're all for the post, and you're just doing the get. And so on and so forth. And so I was writing this, and I came to this pattern where everything that a handler could do had an interface. And that interface basically said, I require authentication, so don't let them into this. Redirect to the login page if they're not authenticated. If they are authenticated, the I require authentication interface includes a current user property. So there's no HTTP context, there's no mocking HTTP context, so when you write your handler and you want to write the tests for that handler, you don't have to mock requests and responses and everything else. You just create an instance of the handler, set the various properties, call the method, and then make sure it did what you expected it to do. Require authentication obviously is quite difficult. You've got to go to the request, you've got to look at the headers, you've got to see if there's a session cookie in there, you've got to check to make sure that's a valid session cookie. And I started, I think I was probably tired, trying to write the expression-based code gen to do all that stuff, because I knew that that was going to be the fastest way to do this. But oh my God, you're just tying yourself up in knots. When you get to the point where you're trying to do try-catch exception with expressions and code generation, it starts to hurt, you know. I mean, it's still, trying to do try-catch exception with the old opcodes and emitting stuff was just brain ache of the first degree, but doing it with expressions is still quite nasty. And then I thought, why am I doing that? Because it's the same code over and over again. And I can actually just put that code into a method, because it is fairly static, and I know the type now that it's got to be working with, because it's going to be working with the context, which is where it's going to check, and it's going to be working with I require authentication, which I know I've got. And so I can write static code. I don't need to do that. And so I've ended up with effectively Lego bricks, but the kind of complicated Lego bricks that Lego make when they're cheating. And they're going, oh, you can make a Millennium Falcon out of Lego because we've made these 2 glass bits that stick together to make the gun turret. And you say, that's not fair. I could have made a Millennium Falcon if I'd had access to injection molding equipment. So this is like injection molding equipment. So all these interfaces just have this implementation, and it's just this pattern. It's a static class, and it has a public static method on there that either returns void or bool, and that's the implementation. And I just plug them together. I look at every handler class you've got, and I look at all the interfaces you've got on that handler class, and I just plug together the various implementations. And if we go to look at, nope, let's just do the right click. I hate MacBooks. You can see that I require authentication actually just has an attribute on it that says this happens during the request phase of the life cycle, and its implementation is over here. And so all the code gen has to do is bung all these things together, and you get this method. And it means that SimpleWeb is ridiculously fast, because once it's warmed up, done that warm-up cycle, there is no reflection happening during the course of a request, because it's all been done once at the start and cached, which makes it very, very quick. So yes, that's my final tip. I hope there was stuff that was in there that was useful for everybody, even if it was just the bit at the start about how TDD is easier if you use dynamic. If that's all you got out of it, then you got something out of it. If you want to follow up on anything, then do come and find me. I'm going to be around for the rest of the day and partying later on and everything, so you'll be able to track me down at some point, probably outside trying to bum real cigarettes off people, because I've just got an electric one. That's it from me. Thanks for listening, and have a just day.